Scale drawings. So we've talked about ratios, we've talked about proportions and stuff in the past. We've also talked about dilations this unit, which is why this is in with this unit. But really we're talking like proportional relationships. So there's that. Here we go. Scale drawings. Let's talk about common measurements. So we have inches, feet, yard, inches. We abbreviate it was inches, and it gets a little like apostrophes. Feet, or it gets that. Yards are abbreviated like that. A blueprint is a drawing of a building that shows a scale so that you can tell how big things are in real life. Blueprints usually aren't blue anymore. Okay. Ask Siri or Google why they're called blueprints. You might learn something. It might be fun. One of the problems with real life measurements is that sometimes they are so big they're not going to fit on a blueprint. And to solve this problem, building designers and architects scale measurements so that they can fit onto paper. Imagine that if you were to build something and you had to have everything like drawn exactly as it was, and you're like, here, look at this building I'm going to build, and then you try and show it to somebody and you have to have a piece of paper as big as the building, doesn't work so good. Somewhere on the blueprint, there is a key that tells you what the scale is. This type of scale is just like the scale factor when we learned about proportionality, or in our scale when we're dilating. Okay, so the scale would tell us that for every half of an inch on paper equals 4 feet in real life, or that each centimeter equals 1 meter, or every inch is 4 yards. We can use the scale factor to find the measurements of the scale drawing or to find measurements in real life, whichever one is missing. So example 1, we're looking at a blueprint for our partially finished house, and it says the scale is 1 inch is equal to 2 feet, or half inch, is equal to 2 feet from paper to real life. On the blueprint, the living room is 5.25 inches long. How long should it be if we measured the actual wall? Okay, so we have 5.25 and it is inches, right? And we have a proportion that says that we want to turn this into feet. 2 feet, and it's a half inch to get us there. So we want inches to cancel out. So when we multiply, you multiply straight across, and then we divide, we get 21 feet. Sometimes the scale factor is called the conversion factor. Okay, a map legend says that a half inch equals 2.5 miles. If a 4.5 inches from South Jordan to Pleasant Grove on a map, how far is it in real life? So 4.5 inches, we want inches to go away. So we're going to put that on bottom. Sorry, that's not an equal, it's a multiply. And that's going to be 2.5 miles. You can't see my decimal. We want inches to go away. We multiply, and we would get 22.5 miles. Okay. On a set of architectural blueprints for a new school, the scale is 1/4 inch equals 2 feet. Find the missing measurement. The music room, the drawing size is 5.25 inches. So 5.25 inches, we're going to multiply that by 2. We want to know how many feet it is over 0.25 inches, right? Because this is inches. So the actual size when we multiply is 42 feet. The auditorium, if we have 156, well, we have 156 feet. We want to go to inches, so 0.25 is going to go on top because this is feet. And we want feet to cancel out. So that should be 19.5 inches on our drawing. The table below gives the dimensions of a bridge and the scale model of the bridge. Find the scale factor of the model. Again, the scale factor to get the model from the bridge, right? Your answer is a fraction in simplest form. So we want the model to the bridge. Okay, so basically pick one, the model to the bridge. Is it the same every time? Should be. If we simplify all those fractions, we get 2/5. All right, and the figure was made with a scale of 1 unit equals 2 meters. Draw the figure with a new scale of 1 unit equaling 6 meters. You can place a new figure anywhere. Okay, so this is 1, 2, 3, 4, 5, 6 by 1, 2, 3. So this means this side is 2, 4, 6 meters long by 2, 4, 6, 8, 10, 12 meters. Based on that scale. Well, we want the new one to have the same measurements, but our new scale is 1 box is equal to 6 meters. So there's our new drawing. Okay, a scale drawing for an apartment is shown below. In the drawing, 3 centimeters represents 5 meters. Assuming that the bedroom is a rectangle, find the area of the real bedroom. Well, if the bedroom is 6 centimeters by 9 centimeters on the drawing, how big is the real bedroom? Well, let's convert it. 6 centimeters. And we want to get rid of centimeters, right? So 3 centimeters to 5 meters. Cancel centimeters. So that gives us 10 meters. So this side is 10 meters. And then we have 9 centimeters times 5 meters over 3 centimeters. So that's 15 meters. So the side is 15 meters. So then the area is equal to 10 times 15, so 150 square meters.